Welcome back to Canvas. So in this video we are going to talk about comparing linear, exponential, and quadratic functions. So again, linear and exponential were from last semester, and now we've just learned this new quadratic function, and remember that's when you've got something x squared, okay? So we're going to review how to evaluate a quadratic function, and remember evaluate means you're going to substitute in this value everywhere you see in x, okay? Now the important thing is make sure you are putting everything in parentheses, okay? Because this lovely squared thing is very important, and if you do not put parentheses, your problem is wrong. So if you would start off first with 3, and then it wants you to input an x, okay? And it wants us to input -2 for x, okay? Your squared will go on the outside, and then you're going to continue with +5, and then it wants you to substitute in another value for x, which is -2. And then it wants you to continue with subtract 7. Okay, now again, you can type this in the calculator just how it looks, or we can kind of do some mental math. So -2 squared just means do -2 times itself. So -2 times -2, which is a +4. Okay, so I'm going to bring that down. We can go ahead and do 5 times -2, which is a -10. And then I'm going to bring down -7, okay? So then 3 times 4 is 12. I'm going to go ahead and get rid of that. -10, -7, okay? So 12 minus 10 minus 7 is going to be -5. So again, you can type this whole thing in your calculator, or you can do it step by step, okay? So why don't you go ahead and try finding h of 4, so plug in 4 into this problem, and then go ahead to try f of 3 into this equation, and then also f of -1 into this equation. So try these 3 on your own, and press pause. Go. Find h of 4. Again, I plugged 4 in into this equation, so I had 3 parentheses 4 squared plus 5 times 4 minus 7. I did some mental math, or you could have typed it in the calculator and got 61. Okay. On this last one, find f of 3. Into this equation. So you're going to start off with 3 squared, -4 times 3 minus 5. Again, I typed that in the calculator, or you could do some mental math, but you would get -8. This one might have been pretty tricky for you because it was a negative number, so if you did not put the answer in parentheses, it would be wrong. So since it wanted x squared, you go ahead and put -1 squared, -4 times -1 minus a 5. I did a mental math. -1 squared is 1, and then -4 times -1 was +4, and I brought down -5. I ended up getting 5 minus 5, which was 0. Okay, so that's a little refresher on how to substitute in for some quadratic equations. All right, so now let's look at determining whether an equation is linear, exponential, or neither. So we know that a linear equation is going to follow y equals mx plus b. So I'm going to have like y equals 2x plus 1. Okay. Exponential equations, hopefully you remember, is y equals a times b to the x. So the x is in the exponent for exponential. So you could have y equals 2 times 4 to the x. That would be an example of an exponential. So for a quadratic, it is going to follow the form y equals ax squared plus bx plus c. Now that looks familiar from when we did factoring. So for example, you could have y equals 2x squared plus 4x plus 1. Okay. You can also not have a b or a c. So it could just say y equals 4x squared. It could just be y equals 9x squared minus 1. Okay, so you don't have to always have 3 terms, but what is the common thing is you have x squared. So you need x squared for it to be a quadratic. Okay, so the tricky thing is exponential and quadratic. So the x is in the exponent for exponential, but 2 is the exponent for quadratic. Okay, all right. Now we need to determine if a table is linear, exponential, or quadratic. So remember, linear is when they are adding or subtracting by the same number. Exponential is when they were multiplying or dividing. And then for quadratic, it is called the second difference. And I'll talk about that. Okay, so first off, how do you go from 5, 10, 15, 20? Well, they're adding 5 each time. Okay, so since they're adding 5 each time, and this side was going up by a 1 each time, it's going to be linear because they are adding. Okay, now this middle one, how do you go from a 1 to a 5 to a 25 to a 125? Well, they are timesing by 5. So this would be an exponential because they are multiplying by 5. And a better way of saying that is actually spelling out the word because and say they're multiplying at a constant rate. Now, that leaves you to say that this last one is quadratic. Now, it would look like neither in the past. But first off, let's see what they're adding by. So here, they're adding by 1. Here, they're adding by 3. Here, they're adding by 5. Okay? I found the first difference. That's what this is called. I found what they are going up by. Now, for quadratic, you have to do it again. So what you would do is, how do you go from a 1 to a 3? They added 2. How do you go from a 3 to a 5? They added 2. So, this is called the second difference. And if the second difference is the same, that makes it quadratic. Okay, so if they're subtracting by the same thing, that's going to be quadratic still, so they could be going up or down just as long as that second difference is the same number. Okay, so a little bit more work on quadratic. All right, so why don't you try this top page and tell me if they are linear, exponential, quadratic, or neither. So if neither of those happen. So press pause and try this top part. For this first table, I got it was quadratic. I saw they were adding 1, adding 3, adding 5, adding 7, and then I saw that those weren't common, but I did see that if I added the second difference, they were adding 2 each time. So that is a quadratic function. In the middle, they were subtracting 2 every single time, so that was linear. This one kind of confused me, so I saw that they were subtracting 4, and then they subtracted 2, and then they subtracted 4, and then they subtracted 2. So just to make sure it wasn't quadratic, I found the second difference. So to go from a -4 to a -2, you're going to add 2. Then to go from a -2 to a -4, you're going to subtract 2. So they were not adding the same number each time or subtracting it, so it was a neither. And then lastly, I saw that they were dividing by 2 each time, which again is the same as timesing by a half. So since they were multiplying, that was an exponential problem. Okay. All right, lastly, determining if the graph is linear, exponential, or quadratic. So let me go ahead and draw some graphs. I'm going to draw 2 examples for these actually. All right, so first off, a linear, it's going to be a line. So if you see a line going up, down, left, right, side to side, that's going to be a linear graph. Exponential, remember it curves. So it could go up like that, it could go down like that, as long as it is curving. Quadratics, any idea? No idea, awesome. They're going to be U-shaped. So we got U's now. So for the next month and a half or 2 months until May, we're going to be dealing with U's. So we're going to learn what those are called later on, but they can go facing upward or they can go facing downward. But if you quadratic is a U-shaped graph. Anything else would be neither. So you try all of these and then press pause and we'll go over them and we'll be done. Awesome. Press pause. So first one I got linear, obviously because it's a straight line. 2 is a quadratic because it's a U-shaped graph. This one is a linear because it's a line. Lastly, exponential, it is increasing dramatically and it's curved. All right, equations, I said this was linear because it follows y equals mx plus b. Over here I have a quadratic because I have x squared. This is a exponential because the x is in the exponent. Again, this one is an exponential because the x is in the exponent. And last but not least, quadratic because my first term is an x squared, okay? So if it has x squared and nothing else, like an x cubed, you are fine, okay? So that is linear, quadratic, exponential, and neither. If you have any questions, let me know. Otherwise, it's time to practice. There are a few IXLs on this. CC1 and CC2 are from graphs and tables, but there's also lots of paper practice as well. So thanks for watching.